Hello, ladies and gentlemen. Welcome to the Burma Nation. Here we are talking about lesson 2.5. So we're going to keep this short and sweet. This is something that's pretty much brand new for your world of math knowledge. So hopefully we can catch you and make it make sense. So here it is. We're talking about solving absolute value equations. Ooh, let's draw a little line here. And so example 2.5 is all about absolute value equations. So what is absolute value? Well, if you remember from last year, absolute value is the distance from zero. So I'm going to write distance from zero. And remember that distances can only be positive numbers. So absolute value bars kind of look like this stuff. All right, stick with me, computer. All right, it's working, I promise. It's going to think about it. Here we go. So if I had the absolute value of -1, well, -1 is only one spot away from 0 on a number line. All right, so what happens here is our job is to be able to solve equations with absolute values. So the first thing, this is something that we should know how to do. We're going to plug this number 5 in for the a. So it's going to say the absolute value of 5 minus 7 plus 15. So 5 minus 7 is -2, so the absolute value of -2 plus 15 is the math that we're doing. Now -2 is 2 spots away from 0, so it turns into being 2 plus 15, which this is the official answer of 17 then. So remember that you're going to keep these bars until we've actually done the one number simplification. So these are kind of like grouping symbols. They are like parentheses. They're going to be, we have to do the math inside first. Big key concepts here, folks. When we're solving equations with absolute values, there's two cases to consider. There's the positive and the negative. So if you think about it, if I were to have a variable of x in here is equal to 6, x could have been equal to a -6 or a +6 for this to still work out here. So that's why we're going to show each equation in both the positive and negative form. So in example A, 2x minus 1 can equal a -7, and 2x minus 1 can equal a +7. So these are the two cases. So you're going to write down two different scenarios. You're going to solve both of them and figure out what x equals. So that means we are going to add 1 to both sides. I'm going to do all these in one step here. It's going to look really, really sweet. And then we're going to find out that those cancel. And it's going to be left over with 2x is equal to a -6. On this one, it's going to say 2x is equal to an 8. And then we're going to change colors again. Same exact processes are going to happen on both equations. And that's why I'm doing them at one time. Hopefully this doesn't confuse you. And then those cancel to make x is equal to a -3. And x is equal to, whoa. Glitchy. X is equal to a 4. So both values of x are the options that we have to make this absolute value equation true. So let's go down to the next one. Same exact situation. You're going to draw out your two situations and solve for them. So I have a positive situation of p plus 6 is equal to a -5. And then their negative situation where p plus 6 is equal to a +5. So what we're dealing with here, folks, is a situation where we see, if I were to solve this, I'm going to go -6, -6, -6, -6. We're going to do some math here. P is equal to a -11, and this one, p is equal to a -1. Now here's the biggest problem. At no point in time can this distance be equal to a negative number. Now I've shown you all this math here because you can still come up with answers, but the problem is that this is not a possibility. There is no way that a distance can be equal to a negative. So this is a no solution empty set problem. There's no number that we can plug in for p to make the distance be a negative number. And although I did show you math, you don't need to do any of that. The answer is just right away, this is a no solution. This is another way of writing no solution with putting a zero that's crossed out. No solution. All right, next example. Example number 3 here says that the average January temperature in a northern Canadian city is 1 degree Fahrenheit. The actual January temperature for that city may be about 5 degrees Fahrenheit warmer or colder. So we're supposed to write and solve an equation to find the minimum and the maximum. So if we have ourselves, it's 1 degree average. So let's say D 4 degrees, and then we're going to subtract 1, because that's our average, is going to be equal to, now it's 5 degrees that we're going to have of a warmer or colder. So the situations here, folks, is this is going to become a positive 5 and a negative 5, because that's our two situations. So I'm going to take all that stuff over here. This is the original equation that we wanted, and we're going to make two situations happen from it. So we have a d minus 1 equals 5, and we have a d minus 1 equals negative 5. We're going to solve both those equations by adding 1 on both sides of both equations. And it's kind of easier to do it all at one step because you're going to do the exact same steps for both problems. Those cancel. D is equal to 6. Those cancel. D is equal to a negative 4. So we've solved and written down our absolute value equation to find our minimum and our maximum. So we're going to then put this onto our graph. Our minimum was negative 4, so we're going to put a dot at negative 4. Our maximum was a positive 6, so we're going to put a dot at 6. And you'll notice that if we were at halfway between here, you can see that the temperature was at 1, and we're 5 to the right and 5 to the left from that exact spot. So this is what we're really looking for. The average temperature was at 1, and we're going to give or take 5 degrees to become closer to that stuff. All right, folks, that's what absolute value equations are all about. We will show you more information, have some practice problems tomorrow when you show up to class. And this is what the assignment that you'll be doing is. So good luck. This is the Berman Nation signing off.